Hello all. Today we're going to study about the function of the router, and in the function of the router we will see five basic function of router. First one, it's like how to maintain the routing table, how it's going to install the root into the routing table. Second function, we will see each port of the router going to assign one broadcast domain. Let me open the whiteboard and uh, let's just select the pencil. So first, as I told you, so we going to see first stuff, the routing table. Second, we will going to discuss about the broadcast domain, how the each port of the router separate the broadcast domain. Means if you have a router 4 port, all 4 port associated with the 4 different broadcast domain, means is define each port associated one separate broadcast domain. Third, we going to see two protocol we have in router function. For router we have routed protocol, a second is routing protocol. So we will discuss about that. And fourth function, we will see AD value and how AD value is directly proportional to the integer value of the respective routing protocol AD value defined by. And the fifth one, we will see the root selection process. So in root selection process, we will see what are the 4 method going to follow while they will select the root and process with the installation of root in the routing table. So let's quickly discuss about this all 5 function of the routing protocol. Then we will move today to the lab edge. We will understand what is the IP nomenclature. To do any lab quickly, we will how quickly we can assign IP if we follow the IP nomenclature. So let's see one by one. The first topic we have, let's yes, function of the router. First topic, function of the router. First point, as we discussed, routing table. What is routing table? Routing table maintain the best route in the routing table. They maintain the best route, so that they can do this route selection of in order to sorry this route selection going to help to packet forwarding of each packet which he going to receive on the ingress interface, and egress they process with those route, and they will start forwarding on the basis of the routing table the best route installed in the router. They will do packet forwarding. For each packet going to be forwarded as per the route installed in the routing table. So what are the factors going help to selection of the route and installation of the route? So we will see the selection process is a fifth function of the fifth rule of the function of the router. So in the first routing table maintained, we're going to see it's going to install the network ID of each network. So routing table going to install the network ID of the each subnet with the associated next hop. Next hop says that if you able to reach this next hop, then you will further going to see how to reach this network. And the next hop supposed to be reachable means this network's going to be reachable, the packet going to be forwarded to next hop. So next hop having ARP resolution, then only it's going to install in your routing table. So routing table maintain three things. At the network ID, entire network, it's not going to install, it's going to install the network and followed by the next hop, and next hop will be associated with the ARP table. Then only if your next hop is reachable, then only that network going to be installed in your routing table. And this routing table going to help for the packet forwarding. I hope this part is clear. Now move to the next function. We have each port of the router associated with the separate broadcast domain. So we have only two terminology. First terminology we have collision domain, and second we have broadcast domain. So collision domain, it's belong to the bridge switches. It's belong to the bridge or switches where each and every port associated with the separate collision domain. Suppose we have 24 port of switch, so we have separate 24 collision domain. So the switch is very smart, which make each port having separate collision domain. The benefit of separate collision domain, if you have separate collision domain, you can achieve the throughput with the full duplex. Means for if you have 100 Mbps of speed, so it's going to show you throughput as a 200 Mbps. 100 for RX receiving packet, 100 Mbps for transmission of the packet. So total accumulative it's going to be a 200 throughput. So due to the separate collision domain, they have full duplex behavior on each and every interface. If it's if you go little early technology, so you can see there is a hub which belong to single collision domain. Now let me draw one example. Suppose this is hub and they have the 8 ports, and so whatever the packet it will receive, it will broadcast to each and every port. Is going to broadcast to each and every port. So this, and due to the within the single collision domain, it's going to behave like a half duplex. It's going to behave like a half duplex. So because of the behavior, it's maintain the single collision domain. It's not separate the collision domain. What do you mean by collision domain? This come with the protocol carrier sense multiple access, collision avoidance, and collision detections. Collision avoidance in wired and wireless technology, they have two. If wired technology, they have collision avoidance means there is no collision required. If you have wireless, then you have collision detection. So in this technology, if you have single collision domain, they have to Ravinder, they're going to select each and every node which one is free. They're going to sense the media. Once it's free, they will assign for the one-way communications. So they will wait once it's going to complete the communication from one PC to other PC, then they're going to start with the PC2. So this is collision domain. So every switch port going to separate the collision domain. Same way, router going to associate it with the broadcast domain. Means if the router having 5 port, or you can take example any router having 4 port, it will associate it, each port going to associate it with the broadcast domain. Means the broadcast going to be drop broadcast packet within this interface only going to be walk. It's not going to cross the router interface. This will be drop, or it's going to filter broadcast. So each port associated with the separate broadcast domain. If we have 4 port in router, means we have 4 broadcast domain associated with that, and they can do the communication between those different network. Okay, so this is the second function. Third function we have, that's called protocol. So we have 2 protocol we should understand on the routing level. So we have first protocol, the routed protocol. The example is, which routed protocol is responsible to carry the actual data from source to destination. You should remember, it's not going to define the route by the routed protocol. Routed protocol going to follow the routing table and the selected best route to reach to the any destination. So routed protocol example are IPv4, IPv6. These are the carrier which carry the actual data from source to destination. IPX, these are the example for the routed protocol, which is real carrier for the data, which is going to carry the data from source to destination, but it's going to follow the route defined by the routing table. Okay, now these are the routed protocol are actual carrier of the data. They're going to carry the data from source to destination. What is routing protocol? This is not going to carry any data. They gather the information of the route from source to destination. If source to destination there is multiple way to reach, they will gather the data, and as per the route selection process, they will run the specific algorithm and they will get the best route to install into the routing table. So routing protocol help you to identify the best route, and it's going to install in the routing table. It's not going to carry any data from source to destination. It's going to carry only the information about route. The example of this, we have RIP, we have OSPF, we have EIGRP and BGP, ISIS. So these are the example for the routing protocol which carry the information about the route, and they help to process with the best route to install in the routing table. So I hope the third function is also very clear. We will move to fourth function, that is called administrative distance. Administrative distance is an integer value which going to show the attributable behavior of the trustworthiness of the route. Means if this means this route is belong to which routing protocol, who has bring this routing means who has installed this route into the routing table. It's installed by the RIP, it's installed by the static route, it's installed by the EIGRP, it's installed by the OSPF, and they will going to prefer one over the other routing protocol by the integer value defined by the administrative distance. So it's a predefined value of AD which is having like directly connected. You can see the integer value for the directly connected switch, sorry, directly connected route. We have AD value 0, and whereas for static we have 1, for EIGRP 90, for summary route for the EIGRP 5, then OSPF 110 and RIF 120. So this administrative distance is reciprocal dependent on the value of integer. Means the higher the value, lower the trustworthiness. So lower the administrative distance is having higher preference in the routing table, or you can see the higher trustworthiness regarding those. Means if you see in the chat, we going to prefer first directly connected route because we have AD value is 0, and this is the most trusted route or most preferred route which is installed in the routing table. It's going to prefer ranks highest preference. Same way we have lesser preference static route than 90, again more less preference 5, again we have higher preference, and then OSPF, then we have RIP, then we can see the BGP and other protocol also. So lower the administrative distance, it's a higher preferred route and which going to be installed in the route. Now come to the last function, that is called route selection process. Route selection process, it going to select the multiple among the multiple route on the preference of the selection list. So first, if you see the in the list preference, it's going to check the longest prefix match. What do you mean by longest prefix match? Let me write some prefix. I'm going to write 192.168.1.0/24, and next I'm going to write same 192.168.1.15/32. So which one going to be more preferred here? Because this is the longest prefix match. If my destination will be 15 and we have two prefix, so we going to prefer the longest prefix match. So this going to be installed in the routing. So higher bit like 32 subnet CID are going to be more preferred than super subnet or lower CIDR. So longest prefix match going to be the best because the maximum network ID matched. So this is the first preference. If it's having same longest prefix match, then it will, if it's a tie break between the longest, if you say, I'm going to say it's again 24 only, so longest prefix are matched. So if it's a match tie break, then it will go for lowest AD value. Second preference, well, lowest AD value. So suppose if the one route we are getting from static, second route I'm getting from OSPF, then the AD value of static is 1 and OSPF having 110. So the preference will going to be the lowest AD value, means highest preference if the same route installed by the different protocol. Okay, suppose the same route is coming from the EIGRP and OSPF. So EIGRP going to be more preferred because the AD value of EIGRP is 9090, which is lesser than the 110. So EIGRP having lesser lowest AD value, or you can say less AD value. So 90 AD value is going to be preferred, and the EIGRP have more preference to install route into routing table over OSPF for the same route. Now suppose if they again come this route from the same routing protocol like OSPF, so they have same AD value. So if AD value tie break, so it will go for the metric. So all other protocol we have different metrics component, right pencil, okay, different, like for EIGRP having GRP having their own metric composite, and we will do the lab on that in detail. So if within EIGRP we have multiple route and those route is tie break because they belong to the same routing protocol, so it will define on the basis of metric calculations. So lower the metric, again higher the preference. So those who have less metric have a higher preference to install the route within the EIGRP protocol in the routing. Suppose all the three parameter tie break, everything is our same, like they have same longest prefix, having same AD value, they belong to EIGRP or OSPF, and having same metric bandwidth if it's a OSPF, or if it's a EIGRP, they have same metric composition, then it's going to start doing load balancing. So in EIGRP we will see we have the preference of the load balancer can be controlled, not 50-50, but in OSPF we don't have, it will do 50-50 load balancing, means 50% of packet going to move from one link and other 50% of packet will move to the secondary link of the load in order to complete the load balancing. So here and for EIGRP we have the process by which we can do the different like 60-40%, 60-40 calculation of the load balancing. We can do asymmetric load balancing, not a equal load balancing. So we will see unequal load balancing, and we will do the lab while we will process with EIGRP. So by this, we have completed the all 5 basic function of router, and these 5 function going to uh, observe and going to discuss each and every routing protocol when we going to do the lab for static connected route, as well as RIP, OSPF, and EIGRP. So we will discuss each and every element what we discussed today, like we can see how to maintain the routing table, and what is the role of next hop, how the network ID going to be installed, and it's followed by the next hop, and the next hop are supposed to be maintained in the ARP table. Second, we will see how it's going to broadcast, and we will do DSCP lab. It's going to break the broadcast, and so we need the relay agent to reach our DSCP server reachability from different subnet to that subnet. They can pull the IP from the DSCP which is associated outside the network in the different net. We will see, and we're going to discuss the routed and routing table, how it's going to work throughout the each and every routing protocol. And we see the role of the administrative distance in the once it's a selections of route, how the AD value going to be preferred one over the other. So okay, by this the routing function of the routers is completed. We will start lab for the connected and static route. Next lab, we will see you in next lab for this. Meanwhile, if you have any query, you can post your query in the classroom portal. And we have lab 12 today. We're going to see the IP nomenclature. What is IP nomenclature? It's while you are going to do the lab, you have to assign the IP throughout the topology. So this part going to be very helpful if you follow this nomenclature. Then we know by looking on the topology, we can say which part what IP going to be assigned. It's a predefined, and we have to stick. Like I have mentioned here, we will do practice today some of how we have to assign the, like LAN. For LAN, we can assign LAN 1, LAN 2, LAN 3, the name of the LAN, and or line A, B, or C, D, like this. But the IP going to be assigned for the LAN 192.168, and this X belong to the 1, 2, 3, and the gateway will be .1. So this is going to be defined for any LAN. You will define, like if you going to select the LAN A, so IP will be 192.168.1.1. if is the LAN B, then 192.168.2.1 will be the gateway. And see, and rest of IP going to be assigned for the stuff for the PC or desktop. So this is the nomenclature for the, or you can do LAN 1, of course the IP will be 192.168.1.1 or 2.2 or 3.3 as for LAN. So you can keep on assign the LAN, and your IP non-IP will be available. So there is so we're going to follow the throughout the CCNA, CCNP, or CCI lab, same concept. If we have LAN, by looking on the name of the LAN, we can go for the subnet. That will be For the router connectivity in between the two switches, so we'll always select 24 because it's very easy to select and it's a handy to practice. Okay, so what will be the nomenclature? Suppose we have router R1 and R2, so it will be 10.0 dot R1 and R2's, then it's 12 router 1 and 12 XY, and if it's a router 1 then it will go to the 1 for router 1 and it will go for dot 2 for the router, so slash 24. So we have 10.0.12.1 for the router 1, 12.2 for the router 2. So same way, if we have let me take on whiteboard, that will be more clear. So suppose let me draw one topology, so that if we have R1, R2, R3 and R4, suppose this is the R4, this is the topology, and I want to assign, by looking on this I can say what will be the IP, and we have this connectivity. Okay, so what will be the IP? So by looking on this topology we can quickly build up for, then we know the my IP will start from this XY and X or Y. So what going to be, so I'm not going to write this part remaining. So this network going to be 12.1, this IP, this will be 12.2, this interface. Same way this interface you have, so 24.2, this will be 24.4. here same way you will get 23.2, 23.3. so by this way you can easily assign unique IP. There is no need to remember, by looking on the router name you can say what is. So what will be the IP for this 34 dot, always you take, like you can say that this is 34th or 43, no, it's a lower value we will prefer. This will be 34.4 and this is 34.3. so here if you see there's a 41 and 114, so I will prefer 14.4 and this will be 14.1. so this way we can assign the fast IP nomenclature and we can start lab without thinking about the IP what we going to, and this going by this method you can give them, you're going to provide the IP, unique IP to your topology, and you can start jump to your lab. And while you are doing the lab, once you receive this route on the R4, the different next hop, you can identify these routes belong to R2 by looking on the last dot 2, dot 2, this belong to dot 2. so there is lots of help by looking on the IP prefix, you can say which route belong to which router. So I have done the CCI labs also, and this is very useful mechanism. Please adopt from CCNA level while we will do the lab for CCNA, and we will give you video for each and every module of lab, so you can, by looking on topology, no need to recall the IP, you can assign IP by yourself and you can start your lab quickly. And I want to add over here, so suppose I have add the LAN, two LAN I have added, like LAN I given, this is 31 LAN, the LAN 32 LAN, so my IP will be 192.168.31.x.24. Same way it will be 192.168.32 dot slash. So we can start our lab quickly here. Suppose R1 having LAN 11 and 12, the LAN 11 and 12, so my IP will be 192.168.11.x. so I can now, by looking on the LAN, what IP will be assigned, and this way we no need to remember the IP, which IP belong to what. By looking on the topology, you can calculate. So by this, thank you guys. You can practice this. I'm going to upload in classroom and you can practice this topology. We will start next class for the static routing and connected route we will see. Bye bye. See you in next class.